Grüezi YouTubers, here is the guy with the Swiss accent.
Today I will try a different format. Recently many YouTubers started to do live videos. I'm not a fan of this format because it is quite long and sometimes for me also boring. So I decided today to experiment with a slightly different format. It is somehow like live, but I will cut out the boring or the most boring stuff, but you still should get an impression on how I work when I do the preparation for videos. So today you see a little bit behind the scenes and we will deal with this tool here, a Sonoff sensor, very nice product, but let's start. Today we want to hack this new Sonoff device. It is called Sonoff SC and has many sensors in it. It has no relay as the other Sonoffs so far, but it has temperature sensor, it has a microphone, it has a dust sensor, it has a light sensor, it has a temperature sensor. Of course, we can also connect it to the app of iTeed. So I try first to pair it to check if the device works. Now this device is different to all others I hacked so far. It does not only contain a ESP8266, it contains also an Atmega 328, which is basically the Arduino microprocessor. And I don't know how they work together, nothing. I just have a, fortunately, wiring diagram, and it says something, but to hack this is definitely different than to hack all the other Sonoffs. First I want to understand how it works. So first we have to pair the system with the iPhone, with the smartphone, and you have to press here about 7 seconds, then it starts to flash. And if you downloaded the app according the manual and everything, you see here that is the application. So it is now noisy. You see, if I talk, it's noisy. It's quite dry here, it's comfortable, and it is dusky, whatever this means. But it seems to be orange. I don't have enough light, so probably we have to change that one. Now I switched on the second LED, the LED for filming, and you see now it's bright here. So obviously this device works, but of course we want to hack it. I forgot, the air quality here is also good. So let's check with a small fume with my soldering iron. So we solder a bit. Now the air quality is now bad. So you see, soldering is not good for the air quality. Real bad air quality. Smoke is still coming out of the device here. Now this was different to Dave Jones because we first tried whether it works. Usually Dave Jones does not test it, he just takes it apart. I can of course not say this apart as he does it in his Australian English, but we take it apart too. Okay, 4 screws here. So we can take it apart like that. And best practice to put the screws somewhere in a safe place. But I think I already, no, I did not lose it. So here it is. Okay, now we see here the 8 Mega 328 and here the ESP. It is not a module, it's really soldered on it with the flash here and the antenna here. The microphone is obviously here, and we have some jumpers and we have some connectors. RxTX, RxTX, so I assume this is to program the ESP and this is to program the Atmega. I don't know what software is running here. And we have some jumpers here, and it's also RxTX, so I assume that the Atmega works with the ESP on serial. And I checked it, and it is really like that. And here, if we go a little bit closer, we see also two transistors which do the level shifting from 5 volt to 3.3 volt. So we have two more screws, and we have also here something we might be able to take apart. We see here the DHT11. We see here a LDR, light dependent resistor, and if we look inside we see two small washers, I think, which are basically holding this here. So I try to get these screws out, and maybe we have to loosen these screws also. It does not come out, so we have I think they are loose. Yeah. So maybe I can catch these. I cannot show you quite well how it works, but you will probably see it later on if I can remove it. No, something something fall out. Maybe I try it again. Yes, it is possible. So we have just a box here, and here is the screw, and here is the whole thing with an SD card, the micro USB power connector, our switch for pairing, and an LED. And this is an interesting device. I never saw this, but this is the dust sensor. It is quite huge compared to other sensors like a temperature sensor or a light sensor or the microphone. They are all small, but this one is really big. And I checked at SparkFun, I think it costs about $11, and the whole device here costs about $20. So it's quite affordable, this sensor stuff. Okay, so I take this apart here, or I don't need it. I don't need to take it apart. I leave it. Okay, now we have to find out whether one suspicion is that here we have some sort of AT commands running. This would make it possible basically that this one just does the whole wireless LAN stuff and this one does the sensor stuff. I'm not sure, so let's check. If this is RxTX, we know that the Atmega 328 only has one RX and one TX, so this must be the same here. So we can check the communication between the two components by looking at these two pins here. And how do we check communication? We can do it either with an oscilloscope, but we already know it's 5 volt. So we have a better tool, and guys who saw my video about making the invisible visible know that the logic analyzer is the right device to work with this communication. So I will connect the logic analyzer to these two pins, and let's have a look how they communicate. I connected now the logic analyzer to ground and to the two channels, to RX and TX, and now we go to the PC and have a look at it. We have now the logic analyzer, and for the moment I just look what happens here. I record for 20 seconds, and because I know it's 5 volt, I choose the 5 volt here. So let's start, and when I start I basically just power up this Sonoff SC and look what happens. Now it's powered up. And now I can stop and check what happens, or what happened, and we see here it powered up and it does its thing here, and obviously there is something like a response. Here maybe it's the call, and here maybe it's the response. So let's zoom into this one here. Now we see, now we know that this is a serial connection, and we see also here we have 52 microseconds. 52 microseconds. Let's check here. This is the shortest one. 52 microseconds everywhere. So 52 microseconds is 19 kilobaud. I just take the shortest high here. It's always 52, and 1 divided by 52 microseconds mean it's 19,200 bits per second. So let's check. We create an analyzer, async 19,200, and the rest we just keep like that. And just 1 second, edit settings, and we want to have it for the moment on the 1. We see something happens here, and we can see AT plus UPD, ATE, and so on. So this is what I expected. The ESP has the AT firmware on it. The old AT firmware, which was delivered with the first ESPs. And obviously this time we do not need, if we want to hack it, we do not need to deal with the ESP, we have to deal with the ATmega. This is a different hack than all these Sonoffs before. And now we can, because we know that this is the AT command, we can check a little bit here. What's the answer is here, and we add another analyzer with 19,200. Oh, we could even check once, use Autobot. Maybe it will detect it, and we put it on the 0. So Autobot does not work without a number, so we just select this one. And we see here nice things, and it's also AT. AT something. So we have to check, but if we look at the whole thing, to analyze, I export first the TX, and we export it as CSV file, which is basically which is basically a text file, and I name it rx point CSV, and now we can import it from text, downloads. Let's check the TX first, and we see here it is separated by space. So basically we are not interested in the time, probably, and we are not interested in the values, but we are interested in the errors, because we have plenty of errors, and the errors usually, if we have an error here, this is also invalid. So we should not look on that. This is probably the glitches from startup, and now we see here the first AT command. So this is really crap here. And we delete it. So we have here AT plus start. Whoop, looks nice. Now let's find the AT commands for the ESP8266 and AT command set. And here we see already the ESP serial Wi-Fi module from iTeat. Maybe this is a good thing. So let's check. Hopefully they use the same AT commands as they have on their homepage. So AT plus start. No, I don't find it. AT plus start is not supported here. Here it is, zip start. Not very good. So definitely this does not look like a normal AT command set. Wow. Let's check just quickly what is on the RX side. So we have also update, comma, and so on. So this also seems to be a strange dialect of these AT commands. So we have to find out whether we find anything about these commands here. Fortunately, iTeat gives us some sample files, and we find this in the wiki of their homepage. And you see here we have a Sonoff SC.ino, and I will have a look into this one now. Maybe we find out what's happening. For that, I copy the file into my Arduino sketches and start the IDE. Now here is the code. So they upload something to a server. They do some debug data. Here is the setup. It's not a lot. Get temperature and humidity. Get ADC sensor, which is probably and the noise. So this is a rather short file. So maybe the things are somewhere in the CPPs and H files here. Now if we look at the two screens, we see here some of the things we saw in the sketch for the Atmega. So the Atmega sends something and the ESP only answers more or less with OK. And sometimes also with a status. So this is quite a strange communication, and I think I have to revise my assumption. I think the whole thing works completely different. It might even be that the ESP is the boss here, and the Atmega is just the guy who collects the data and sends it to the ESP. But for sure, if this is true, I do not have the code for the ESP so far, or at least I didn't find it. Now I think we have basically a decision to take if we want to hack it. So basically we have to decide who is the master, but then who is also providing the support. We can do the ESP as the master, then we could flash the old AT software to the ESP as my first suspicion was. Then we could use some Arduino stuff, and basically we could deal with the whole thing like as it would be an Arduino. Now if you are used to Arduino programming, this is probably the way to go. On the other hand, we could use the as it is here, we could just keep the code of the Atmega, which just provides the readings from the sensors, and then we would have to write the whole coding for our application in ESP and upload a new program to the ESP. Both are concepts which would work, but because the ESP is much a stronger CPU, and also because I did a lot of work now recently with the ESP, we find also some MQTT stuff and things like that for the ESP. My decision would probably be to keep as much as possible the 80 mega software and go with the new software for the ESP. Now this is where I stop for today. I think there is still a lot to be done to do the flashing for the Atmega, to do the flashing, or maybe not, to do the flashing for the ESP for sure, because here we have no code, and also we have to find out whether it's a bootloader here and so on and so on. So maybe I will continue with this hack later on, but for the moment, because this was a new format, I would be glad if I get some feedback if this is interesting or if this is boring. It is of course much longer. We do not reach a lot in 20-30 minutes, but on the other hand, you see a little bit how the thinking process works if we do something. Usually with my normal videos you do not see all this stuff because it is behind the scenes, or it happens behind the scenes, and maybe it's interesting for you, maybe it's boring. Just a comment. But still, I hope this video was useful or at least interesting for you. Bye.